From my experiences, every time you scale past a handful of services, trying to figure out why the system made a specific decision after the fact becomes really painful. I've watched a lot of teams solve this with agents by throwing every tool into one prompt and then letting the model figure it out. It works fantastic in a demo. Then you scale it and you get the same mess, except now the black box is an LLM instead of a microservice. So I decided to build a capability arbitrator to put a decision layer in front of execution so the system tells you what it chose and why before it ever acts. The agent's job is narrow by design. It decides what a request needs before anything executes, and everything after that decision runs on deterministic code, a scope skill, or a human review, whichever fits the task. The judgment call is only place the LLM belongs in the entire system. So the architecture is where every request is classified first, then routed to exactly one path. For example, we have math, DevOps work runs through native code with zero LLM cost, and then open-ended work goes to a scope skill instead of bloated general purpose prompt. Anything risky or low confidence will stop for a human to approve it before it ever runs. And every single request will leave a record of what it was, where it went, what it cost, whether the outcome passed review. So what we can do is, for example, we can watch some requests come in. So we can start with a math problem. For instance, what is 847 times 293 minus the square root of 1936? And we execute. What will happen is it will route straight to a deterministic code and log 0 LLM calls. And you can see our route here. And then our second request is we can try to pass an arbitrary PII violation, the social security number, which will immediately come back and ask me to stop. Because the system catches it before the model ever sees it and stops for human approval. So there's no LLM here to ever touch this data, right? So we'll just stop this. And I can kind of high level show the architecture here in the flow where it comes through, does the screening, the approval, compliance judge, and then boom, it's off to some telemetry. And then the last example is I can send a vague request referencing something from an earlier conversation that the system has no access to or no context about, right? It'll realize that it can't classify it and then escalate to someone instead of guessing what to do next. So let's do some math calculations and maybe look up code files or write a summary. Just do something. You're an LLM. Do something. Well, we come back. We're 50% confident. And obviously, we're going to be stopped. And he's going to come back and tell us maybe this is an MCP call. Maybe it's not. I don't know. Do you want to try it? Sure. We'll try it. And then it's going to eventually make the call and tell us that I can help you, but you need to give me more information. Clarify what you want, right? Which is great. So that's the intent behind this. And then while all of this is going on, I'm actually keeping track of some statistics, high level, right? Talking about stats for nerds HUD, where we keep track of like the latency, PII detected, how many times, the footprint, so on and so forth. We can turn it on and off. And then we talk about the efficiency gains. We talk about token savings rate, financial savings, deterministic offload, how many times we've approved, denied, HIDL, so on and so forth, right? And then this is built on ADK 2.0 with Gemini as the model, and MCP for tool connections is deployed through a unified service you can run locally or push to cloud run. and every routing decision is covered by automated test. There's not spot checks. So the behavior you see in this demo is the behavior that gets caught if it regresses. And then honestly, I wanted this to be a straightforward conversation and demo, because to me it matters more than the pitch itself. So the token and dollar savings on the dashboard are estimates against a modeled baseline. They're not real cloud bills. And then what is real is the 0 LLM cost pass for deterministic work, the PII catching before model exposure, and the confidence-based escalations. And then I also included some moonshot items around self-healing security and some other things that you can find a vulnerability, that allow you to find a vulnerability, patch it, and then test the patch. And then you can open a pull request automatically back against GitHub. It's experimental at the moment. And turned off by default. So you have to turn it on. And then I'd rather ship something narrow that does exactly what I claim than something broader that requires trust that I haven't earned yet. And in closing, I built this because I was really tired of agent systems that work until someone asked, why did they make a decision or a choice that they made? And there is no answer. Usually you just kind of go back and go through it and go, okay, it's non-deterministic. I have no idea why I decided to do that, to let me tweak my prompt or add a tool, blah, blah, blah. So this actually gives you an answer before the system actually acts and not after something breaks.